In the number of absence and the test score example, suppose you want to construct a 95% confidence interval, estimate the mean test scores for the entire population of the students who missed the class 3 times. It's going to be a little long process. Let's start with so this is our data, one absence test score 95, three absence test score 80, four absence test score 75, etc., etc. Let's run our regression analyze one more time. Data analysis, regression. Our input range is test score for y range, and input range for x is number of absence from D2 to D22. I check labels because I highlight the labels. Confidence interval 95%, and I want the output to be on G1. Let's click OK. So this is our output. So we already talked how to interpret the output in previous videos. So we're going to start to enter our data here for the confidence interval estimate. Our x value is 3. If somebody, so what is the confidence interval for 95% for 3 absence? So 3 absence, 95% confidence. Our sample size is 20. Degree of freedom for this test is n minus 2, sample size minus 2. That doesn't change, so it is n minus 2. And the t-value for two-tail test, as we already seen this in previous chapters, t inv 2t 1 minus b5, because we want to put 5%, alpha is 5%, 1 minus 95%, degree of freedom b9, and the answer is 2.1009. The sample mean is the mean of our sample. Let me just show you very quick. So we go home, we need to take the average, not the total, we need to take the average. So the average of our data, number of absence for 20 students, is 3.45. So I put here 3.45. Sum of square differences. So we never used this function before. Sum of square differences. The function is DEVSQ. DEVSQ. So I click OK here, and then I highlight the data, our x values. So 72.92. So DEVSQ D3 D22 72.95. Standard error of estimate, it comes from our output. Standard error of estimate 4.005. And age statistic. So in order to find the age statistic, I like to share the formula again. The formula from the book. Let me put it right here. I'm going to paste this here. So this is going to be the formula we're going to use. So as you see in here in the formula, age statistics equals 1 divided by n1. So let's see here. 1 divided by n1, which is b8. Sample size was 20, which is b8, plus b4 minus b11. b4 is our x value, b4, which is 3, minus b11, the sample mean, and square this, if you look at the formula, and divide it by sum of square difference, which is B12. So B12. Now, so we are done with H statistics, and now we need to find predicted H value, this value. So the way we find this value, remember, we're going to use these two numbers, intercept and the slope, for the regression line. So this equals intercept plus parenthesis slope times number of absence, which is 3, so I put B4, equals 82.34. So I'm going to change this to 82.34. Let's put 06 as well. 82.3406. And then, in order to set up our confidence interval, so we need to find first this part here. So t value times, so t value, which is B10, times SYX, which is B13, standard error of estimate, B13, and times square root of H, which is SQRT B14. Now, once we find this, then we need to subtract from our estimation and then add to our estimation. So this is B15, which is B15 right here, B15 minus B18, and B15 plus B18. So we can conclude that overall class, if the students missing 3 times, their grade will change between 80 and 84, 80.40 and 84.27. That will be 95% confidence. The people in the class who missed the class 3 times, their grade will change between 80.40, 84.27 with 95% confidence. It might be 5% chance the mean of the students missing 3 times might be more than 84 or less than 80.40.